Right. Thanks, Phil, for keeping the prize for later. It almost makes up for the fact that I wasn't too impressed when Phil asked me to present after Evan, because I've seen Evan present before and I know what an amazing speaker he is, so very hard act to follow. And it was kind of throwing salt on the wound because he did win the bet, because we had that bet. He said, should we ask Evan? I said, no, he's never going to come and present to us. And I said, okay, let's put a bet on it with better beer. This is all on email. So about 10 minutes later, I get an email just saying, you owe me a beer. 10 minutes after that is, can you present something the same night? So I'm not very impressed. So a very different kind of talk, very technical. As the title suggests, getting started in text mining. So I'm just going to cover the very basics of how to get started. If any of you have actually done text mining, chances are you're not going to learn much tonight because it's really covering the basics. If you're hanging around for the prize and you're getting bored, there's a nice little bed over there, or maybe help me with some of the trickier questions. Okay, so I'm kind of starting from the point here. Those who haven't done any text mining and you're here to hear about it, this is probably what you're thinking, that it sounds really scary. How on earth can I do text mining? So I'm validating that feeling. It's like I've got two young kids, and whenever they get upset or get angry or scared, the first thing is to validate. Yes, you're right. It's fine to feel scared. So that's what I'm doing here. It is pretty daunting to begin with when you've never done it before. So hopefully I can help you get over some of that tonight. This is why it's scary, because we're used to structured data like this. So you get a nice spreadsheet with nice numbers and labels and categories of things that you're trying to correlate with dates. You're used to that. Here's a more familiar data set, the iris data set, that you're trying to classify data into 3 categories, types of flowers, and you've got some inputs, the sepal length and width, and the petal length and width. So you're trying to, from the input, come up with the categorization. And you can do nice things with data like that. So you can build reports. So your categorical variables, you can build bar charts, and your numerical variables, you can build histograms and see what the distribution is. And you can do analysis, so you can plot 2 of your numerical variables against each other in a scatter plot, and you pose the classification and see how the data is clustered together. And you can do modeling, so you can build like decision trees to predict the class of your inputs. Really cool stuff. But so we're used to the structured data, but we're not so used to these kind of stuff. So Facebook and Twitter and emails and text messages and instant messages and open-ended questions from servers where the respondents enter a big long text comment, or a bunch of documents, Word documents or PDF documents, and you're trying to mine them and find patterns in them. What the hell do we do with that? Or you're crawling the web for blogs and websites, news, files, stuff. How do you get started doing anything with that? So, yeah, how do we get started with this unstructured data? So they're scary. Well, we structure it. We're going to go from here to here. But of course, how do we do that? So, bag of words to the rescue. Thank you, Evan, for mentioning it. Bag of words. That is one of the most common techniques out there. There's others, but this one by far is the most popular and very simple and does the job most of the time. What is it? Well, before we get into that, the first thing you've got to do is get all your data into one place. So there's no point having it all over the place. Get it into one place and start structuring the way you think about it. So what I mean by that is put it into one place and start to think about each of your items as a row in a spreadsheet. Think of your collection as a corpus, where each item is a document. So we're not actually structuring the text yet, we haven't touched the text yet, but we're structuring the way we're thinking about it, turning it into a data set, because we're used to thinking in terms of a data set. And this can be anything. It doesn't have to be a spreadsheet like here. It can be a table in a database, or it can be an array in a Java program, or whatever it is. Just structuring our stuff, our text items into a list. And each one of these can be one document, so it can be a whole PDF document. It can be one comment from a survey. It can be one text message. Or it might make sense to break things up into sentences. So you might, each one of these could be just one sentence. It depends on what you're trying to do. But a good starting point is just to think about how the problem is structured. So I'm going to show you how Bag of Words works. So I've taken the first two rows there and put them on here. It really is quite simple. The first thing you do is you extract all the words. So in this case, I've taken its and very, and all the other words from that first document. And I've taken all the words from the second document. And I've merged them together. Voila, there's a bag of words because I've thrown all my words into a bag. I think that's why it's called bag of words. And of course, there's loads of these, right? So you just take them all and you merge them. So you remove duplicates, and it's handy to sort them so you can see all the words that you have into your bag. And then you stick those words as you make them columns in your spreadsheet, your table, whatever it is, the structured object that you're using. And you put some data. What is that data? The most common coding that people use is a binary coding, which is simply the presence of the word in the document. So, in this example, the word long, there it is, appears in the first document, so it gets 1, doesn't appear in the second document, gets 0. And the other words, so we've got R, it is in the first document, along, we've talked about that. Second document has always, there it is, and answer and any, so 1. And of course, you've got lots of columns. The second most popular kind of coding of the data is known as Tf-Idf, which stands for term frequency times inverse document frequency. It counts the number of appearances of a word within a document, so the number of times the word appears in one document, and then weights down by the number of other documents, so by the number of documents in the corpus that the term also appears in. So the idea here is that words that appear in many documents are going to be less discriminative if they appear everywhere, not going to be as important, so we weight them down. That's the idea. So an extreme example is it's going to appear a lot, so there's a pretty small number there. And there's lots of different variations of Tf-Idf, and there's different weightings you can put on the Tf part or the IDF part. There's lots of different versions, but the basic one, again, does the job most of the time. So instead of binary numbers, you get floating numbers. So it's pretty good. It's mainly good when you're trying to find similarities between documents. So you actually care about not that they're using the same words, but they're using them with the same frequency. But you don't want to. But you want to ignore the really common words. You don't want them to influence your similarity. And voila! There's a structured data set. Yay! So numbers. We like numbers. So we've gone from this. Now we can ignore this. And we've got this. So here are document identifiers and columns and numbers. So we can do, so we've done this. We've gone from scary to yay, I know this. But how can we get a bit more clever about what goes into the columns? Because as you can imagine, there'll be loads of them, lots of columns, because there's going to be lots of different words that can appear in our corpus. So how can we be a bit more clever and just cut it down a bit? So the example of the another way to get rid of those kind of words is just to remove them. So remove frequent words. You can count how many documents the word appears in and just remove it if it's too common. Or also quite common is to maintain a list of stock words, and you can just download them from the internet quite easily. And there's different ones for different languages, and you can go in and edit them, so you might not like some of them. So you can use that list to filter out the words you don't care about. You can remove also infrequent words, because these are not that frequent. Well, you have to be careful here, but if you believe that they're so infrequent, they're not going to help, but they're just adding inefficiencies in your processing, because you've got all these extra columns you don't need. Put everything in lowercase, so you don't want to treat two things as different if the only difference between them is the case. Stemming, merge different forms of the word, of the same words. For example, run, runs, running. There will be occasions where you do want them to be treated differently, but in many applications you don't, so you don't want to kind of count them twice. Anagrams is when you combine words. So for example, log in. So instead of treating them separately, you treat them as one entity, one column. Regular expression substitution. So I work at isolate, by the way, as a donor. So I've done this, and when our customers enter comments into our surveys, they can appear in different forms. So I don't want them to be different. I want to, whenever they mention isolate, I want to know. I want all the evidence to be collected together. So I use regular expression substitutions to find all the forms of isolate and turn them into one. You can break words up into chunks. So again, using the isolate example, I've broken them into 4 character chunks. And that's pretty good if you think there's lots of typos in your data. Typos are kind of shorthand, and you want to treat 2 documents as the same, even if there's typos in them. So if I had a typo and I mistyped the E and the C here, I would still have 3 words that match, 3 out of the 4. So when I did my similarity between the 2 documents, it would still give me a good match. So that's a pretty common trick. And there's loads more. So there are just a few. What this means is that we're no longer talking about words. So I keep saying words in the columns, but they're no longer words because we've cut them up, we've put a few things together, we've done lots of things. So they're more commonly known as tokens. So the things that we talk about are tokens. It can be anything. How do we get a lot more clever? So I've shown you some really easy tricks. How can we get a lot more clever than that? So the techniques that I showed you on the previous slide, they're known as shallow techniques. So the kind of shallow processing. So all they do is refer to how the text looks on the surface, how the words appear in the letters. But we can go deeper. We can go deeper into the meaning of the text to try and extract the meaning. So and then group tokens that share the same meaning, so that if we have 2 documents that are about the same thing, they can be treated as such even if on the surface they express differently. So an example here is, I was in a hurry, I had to run off. There's on the surface they're completely different, but we know that they share a meaning. Very, very hard to do. Very hard to do. And the techniques broadly fall into 2 categories, and Evan touched on this as well, this kind of trait, this dichotomy. So one is like a dictionary-based approach, where you have a database that tells you about expressions or about synonyms or semantic groupings of words and expressions. On the other is a statistical data-driven approach. So there's pros and cons to each. So the first one is very hard to maintain, and you need one for each language. And even once you've got it, you've got to keep maintaining it and keeping it up to date. It's very, very hard, but it's obviously much more accurate. The second one is less accurate, but you don't need any domain knowledge. You don't need the dictionaries. You can just always retrain your model if you have enough data. How clever should we get? I hate when people give me that answer, but I use it too a lot. It depends on the application. It really does depend. In other words, how accurate does it need to be? So one thing it depends on is the volume. Typically, the more text you have, the more you can get away with the shallow techniques to capture the important patterns. Whereas, if you don't have as much data, that becomes more of a problem. Also depends on who you've got on the case. Have you got a good analyst? Because the more complicated techniques, someone knows what they're doing. Do you have a domain expert or a stakeholder who can provide some semi-automated feedback to the system? So in other words, if you can get away with a system that's less accurate if you've got a human that gives it feedback and the system can learn from the feedback. They're not always easy to find those people. Really, what I'm trying to say is that the output of a text mining system typically can be broken into three. So the output itself of the system. So it's the positives that the system is very confident about. So there'll be times where it knows for sure where two documents are the same, or when a particular document belongs to a group of other documents. The negatives that the system is very confident about. So these two documents definitely aren't the same or aren't similar. So you've got definitely are or definitely aren't. And everything else in between where the confidence is kind of low in the way, you're not sure. And those true positive and true negative rates can be increased with more advanced techniques. So again, it depends on how accurate it needs to be. Right. So that's pretty much it. Like that's the basic stuff of how to get started. So I'm going to demonstrate with an example from a work that I've done in iSelect. So using iSelect testimonials. So what's this? So those of you who don't know iSelect, we are a comparison website. We provide a comparison service to people who need to compare stuff. Mainly health insurance, but other products as well. And as well as doing the comparison, we offer the capability to actually purchase the product directly from us. Anyway, I'm not here to sell iSelect. So here's one of the pages, and we like to show our users testimonials from previous customers. So here, as I said, very easy to use. And ultimately, we've collected lots of these testimonials, and we present them randomly at different times. So ultimately, this project was about identifying which testimonials kind of give the best, give us the biggest uplift in terms of our success rates, or our continuation rates. So people going on to the next page, and ultimately conversion rates, people who actually transact with us. And we want to go into, we don't care if it's very easy to use or easy to use. We want to know which content is most predictive of that success. Unfortunately, we haven't got that far. We started off with, let's just see if we can group the testimonials into groups, into similar groups.
So does that mean you only use the positive testimonials?
Well, currently we do. So currently we have people who look at them and choose them. But ultimately we shouldn't need to. If the system learns which ones work best, yeah. I imagine we'll always filter out the really bad ones. So again, so what I'm going to be showing you is that clustering application where we just want to find group the testimonials into clusters. Here's some examples. Yes, some really good ones. Voila, yeah. If I knew it was that easy, I would have done it years ago. Yeah, iSelect really does work. People love us. But I'm not selling the service. So there's lots of, here's just some examples of comments that people leave. So you can see that, that some of them, not all of them are as short as you saw in the previous page. They go into real detail. Here it is. First of all, I'll put it all in one place and thought about it in a structured way. So, yeah, there they are in the spreadsheet, the comments. I've got other bits that I know about what these people are, so I could try and find patterns that are related to all those other things. But for now, I really just want to cluster them. So I've done some pre-processing. So I've removed testimonials that are less than 20 characters. There were just the really short ones that weren't that interesting. I've merged those. I've done the regular expression merging for iSelect, transform everything to lowercase, remove stop words, apply slimming, build n-grams, and remove low high frequency tokens. So I'm going to show you what that looks like now. I've used Rapidminer. Anyone use Rapidminer? Yeah. So it's a tool that I quite like using. It's got lots of the text mining, all the tricks that I've told you, they're there. It's pretty cool for getting started. I like it generally for data mining because it's got this nice, visual flow where you can put in your operators and see how things flow, and you can interrogate each object as you go along and try different processes and quickly switch between processes and all sorts of stuff. So I really like it. So I'm just going to use that to demonstrate the example. First I want to highlight, so I've used the Tf-Idf coding, and I've removed words, and I've used kind of a percentage-based filter. I said remove anything that's less than 5% or more than 90%, that appears in less than 5% or more than 90%. I could have also said use an absolute filter and said I need my words to appear in at least 5 documents, 100 documents. So I'm going to show you step by step how it looks like. So let's take that sentence to begin with. Very easy to use. Thanks. So it goes in, then goes to that first operator is a tokenize. So this is what it does. So Rapidminer is just showing me the tokens using the different colors here. You see the alternating colors? Is it coming through? Not so clear. So this is pink and this is purple. So that's a token, that's a token, that's a token. I've got 1, 2, 3, 4, 5 tokens from that sentence. The next operator is a transform case. So I'll turn everything to lowercase. So if I had 2 comments and they were exactly the same, but one had the capitals and one didn't. If I didn't transform case, then a similarity metric would tell me they're different. But I know that they're the same. I don't care about capitalization. Sometimes you do care about it, so you don't do that. Then I filtered out the stop words, so that took out 2. So it's a stop. It's known as a stop word. It's just a common one of those words that it's used to connect other words together. It's also filtered out very. So I'm not actually that happy about that. So I can go into the stop word list and say, take very out of the stop word list. It's not a stop word. I like it. I didn't bother in this case, but I could have. Then I do the stemming. So it's turned easy into easy with an I, so that words like easier and ease will also appear like that. So I don't care if it's easy or if they're talking about ease of use or it's easy to use or it's easier than other websites. I want all instances of those to appear like that, so I collect all the evidence together and then I'll know it's a strong topic. Similarly, use was turned into so for using and used and so forth. And thanks was turned into thank. So if they're going to say thank you or thanking you, it's all the same to me. And lastly is the n-grams. So I've asked for 4 n-grams, but in this case I only have 3 tokens, so I'm not going to get 4, but it's giving me all combinations of 1, 2, 3, and 4. So we've got our easy is, and easy is thank, and is, and is. All the combinations of those 3, well, up to 4, concatenated together. So that's n-grams. So that I can capture things like, if they're saying this, the service was easy, as opposed to the website was easy to use, I actually want to know them separately. So that's why I've asked for the n-grams and other types of expressions. But that's the only meaningful example in this case. So here's the transform data. So for my spreadsheet, so I've got all my testimonials. So I should have mentioned, so in this case, it's obviously each row is 1 testimonial. There's no point breaking it up into chunks. It's each item is 1 testimonial. And here are my columns. You saw easy and easy. I can tell you saw in the other slide. And because I use Tf-Idf, I've got the floating numbers. So the word compare didn't appear. Gee, that's a bad example. Because we're about comparison. These examples, none of them said anything about compare, but we talked about the cover, because we're about health cover. Easy to use. No one mentioned the fund in this set of 10 documents. Good, great, yeah, and so forth. Great site. So the next step, now I can do anything I want with this data set, right? It's just now it's a structured data set. So I want to do clustering. That's just what I wanted to do. Ultimately, what I want to do is build a model that predicts from all these testimonials what was the outcome, what was the conversion rate, what was the conversion outcome. Did they buy? Did they move on to the next page? So then I can build a predictive model from this numerical input to my binary outcome, whatever, any other outcome. But we never got to that. So all we did, sorry?
Just wanted to ask, are the testimonials left on for the same amount of time and same times of day?
I think so. They get rotated. I'm not sure. Yeah, they do because it's automated. So there's a list of testimonials that the system knows about, and they get rotated.
Can you ask? How do you deal with a situation where you've got, say, negatives coming across in this project? Negatives coming across, so if someone's saying, I'm mocking these, rather than saying it's difficult to use.
That's one of those hard problems.
Cynical comments as well.
Sorry?
Some cynical comments.
Cynical comments, yeah, very, very hard to detect. The negative versus positive, so let's do with sentiment analysis, and there are techniques. Aren't there? No. It was really just it was a bit of a pilot project, just to see what can we do with this data. So yeah, but that would be the logical next thing to do. But we have to remember that these are testimonials from people that have watched with us. So mostly going to be it's going to be positive, yeah. But we also have NPS data, so that's going to be interesting to look at the positive and the negatives. Yeah. So I chose a clustering in Rapidminer, a clustering algorithm called the EM clustering. I like it because it's probabilistic, and you don't have to tell you how many clusters you start with. It just discovers how many clusters and does the clustering. So I really like it. I'm not going to go into detail about that because that's a topic for another talk. Here's the output. So the way I'm visualizing the output is here are some of the words, or tokens I should say, the tokens that were used in the data, and the algorithm gave me 8 clusters, and each square, or the darkness of the square, is the frequency of each of those tokens in the documents that are part of that cluster. So where it's darker, it means that that token is more prominent, so you can kind of say, right, that's what that group of testimonials is about, because that's the token that's most frequent in it. So, so for example, this cluster, so easy, is very prominent, unlike this cluster, which is more specifically about the ease of use. So it's a bit more granular, a bit more specific. Then we got ones about help, cluster 2, and this cluster about it being a great site. So these are really encouraging results to see that the testimonials naturally group into clusters that we can then go interrogate more what they're about. We had an interesting one, which is cluster 7. I'm also showing you the number of testimonials and the average length. So this cluster, the average length is much higher than the other ones, and the most prominent term is I. So I'm kind of inferring that these are people that are giving us a whole story. So it's longer than saying I did this, I did that. So that's interesting in itself. Not that I use the length of the testimonial as an input to the clustering. It was just an emergent little quirk. Let's take some more advanced topics, which I'm not going to get into now, that people often look at. Part of speech tagging is one of them. So this is where you break, where you impose the grammatical structure into your data. So if something is a noun, you know it's a noun, so you code it that I've got a noun here, or a noun phrase, or a verb. And so if you're comparing two documents, you might care that they have the same number of nouns, or that they have both nouns and verbs. This is something people often look at. From my experience, it usually doesn't add much to your either predictive power or whatever it is you're doing. Latent semantic analysis, I haven't touched on that. It's related to principal component analysis, where you, in fact, that's pretty much what it is. We're looking for latent dimensions. So, we've got this huge dimensionality in our data, can be 10,000 or more. Columns, so you use something like principal component analysis, PCA, to find the important 4 or 5 hidden dimensions, and then you can say, well, here are my kind of hidden topics or hidden meanings in the text, and you can interrogate your components, your principal components, to see which which tokens make up those components. Again, it's another form of clustering. Topic modeling also is a form of clustering, which is receiving a lot of attention recently. I'm not too familiar with the techniques there and how much they differ, but it's starting from a point where you're assuming that all the text that you're seeing is generated by a finite set of topics. So wherever that text came from, there was 5 or 6 things that generated them. So it's about finding out what those things are. And finally, sentiment detection, which we touched on, also quite popular, where you might not care so much about what is said, but you want to know if it's positive or negative. People are saying good things about you or bad things, and I think it's still a very hard problem. I don't think it's been properly solved, but often it doesn't really matter, because if you're looking at things like trends, you don't care if you really got the sentiment right, but you want to know that it's going up or down, and that can be quite useful. There's quite a few other advanced topics of text mining. There's some of them that I think are some of the most common ones. I think that's all I had. Some resources. So I've talked about Rapidminer. It's open source. It's free. You can download it. It's got really cool out of the box things ready to go. It's got a visual component, so you can quickly try things and see what it's doing. R also has a text mining package called TM. It's also got topic modeling. It's been a while since I've looked at it. It's got a few things now. R, so also it's open source. Python is a very popular library called NLTK. It was developed by people here in Open Uni. Also very popular. It'll do the part of speech tagging that I talked about. It'll do whatever is in the natural language processing, the NLP space. The latest stuff will be in there, so that's a really good one. Word clouds. Phil, where are you?
Yeah.
Why didn't we use word clouds this time? I was counting on it. We use it every other time. So,
I do apologise.
yeah, okay. So you go, so one example is Wordle. It's a website. You input into it, I think, a CSV file, or paste some text, and it'll give you a nice, show you what the key words are. The more common words will be bigger, the less common words will be smaller, so it's really easy to visualize.
If you look at the Meetup website, the background is done with Word.
Yeah, the background was the Meetup website. It's got a Wordle at the back of it. So, and it's from the. Is it from what people said that their background is? I think?
People's names.
People's names as well. All the commercial analytics software. That was a nice little sell point for Evan, but it's not an SPSS. So if you already have those, chances are you can get text mining. Probably have to pay a bit more, but they'll have it. And then there's specialized text mining software. The one I know most is called Leximancer, but there's lots of other ones. So there's quite a few places where you can download resources to help you get started. And hopefully, I've shown some of the tricks I've shown you will help you. That's pretty much it. I mean, to get started, that's all you need to do. And then you learn some more tricks, and you learn how your text works, and you learn what else you can do, and you know some of the terminology, so you can look at it. That's it. The scary factor is gone, so you're good to go. All right, that's it. Well, you're not coming back?
Any questions for you, Don?
No, questions? Any more questions? Yep. It was a pilot project, and we just want to see what can we do with this data, really. But I think there is a valid application, which is if you don't have to read all the testimonials, because we get lots of them. This is a way to help you focus. So you can say, okay, from the 50,000 testimonials that we have, they group into 7, and we can see roughly what each one is about. So today we're going to look at those that say great website, that are about the website. So we're going to read a few about them and see what they're saying. Tomorrow we're going to look at the ones that are about ease of use. So it helps you to focus, and know what are people talking about. What are the key topics that they're saying that they're talking about. So you can tailor the website, the experience to those kind of conversations. But as I said, it was just really just to see what we can do. Ultimately, we want to take the sentiment into account, identify which are those kind of testimonials that have the most impact on the outcome, on actually converting that customer. That's the powerful stuff. Yeah, absolutely. Yeah, the work time is pretty cool.
And you do any kind of filtering before you do tokens, for example, they were talking about it's not easy to use. So you can combine not and easy with the filter before you separate it as separate verbs. So if you give the negative meaning to that, so you generate a negative verb.
Yeah, absolutely. So you can, that could be one of your... Yeah. I think actually there's one lot.
The negative from the negative, so you can have other sides that are easier to use, and no other side is easier to use.
And look, and if the data you're looking at is so specialized that you know those patterns exist, well, you just code for them, you know. But then it's not so data driven. But there's ways around it. I think the word "not" is actually in the stop word list, so it was probably taken out altogether. So, but typically with sentiment analysis, you have your own lookup list where you say each word its polarity, whether it's positive or negative, and even expressions. So as well as the stop word list, you use another lookup list. Or even better, if you can have someone to annotate each comment or each testimonial to whether it's positive or negative, then you can build a machine learning algorithm to learn which are positive and negative expressions. That can be hard to do, to get someone to annotate so many. Yep.
Do you have any software which you can extract some kind of concepts from the text and the relations of those concepts without knowing what kind of language it and how the concepts are related to the kind of the whole text and maybe in time to different documents?
Absolutely. I mean, I think that's what topic modeling is about. And the software that I mentioned, it's one software that I know, LexiMan, so that's exactly what it does. It finds concepts and relationships, it will actually map them for you and show you the connections between concepts.
So if you like to look at some kind of article,
Start with topic modeling. It's a good one. Yeah. Question is about sarcasm, which someone else has mentioned it too. It's very hard, and that's one of the problems. Again, the more data you have, if 5% of your data has sarcasm in it, well, a robust algorithm will generalize operating won't care. If your data set is full of sarcasm, you're in trouble. If it's always the same sarcasm, yeah, it's hard. Yes, Ross.
Some of the clustering algorithms are not, well, they're stochastic, not deterministic. So do you have any recommendations about validating clusters that you end up with?
I suppose you can run it repeatedly and see if you're getting similar results, the kind of the old cross-correlation type thing. But because you don't know the true concepts, it's unsupervised, it's obviously harder to validate. I find often just eyeballing helps, but of course when you've got lots of it, it's harder.
Have you done any sort of human assessment and then compared that back to the automated results?
I haven't here, but that's typically what people try to do. Like if you look at academic papers, that's how people, that's the most ideal validation. And you want to get more than one because it can be so subjective.
Yeah.
That's the thing with language, it's subjective. So you want to get as many people as possible to validate it, and then look at the kind of evaluator agreement.
Yeah.
You're all dying to know the winner, I think. So it's what you feel. Thanks, Yuval. Round of applause for Yuval, please.